Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Ladies and gentlemen, welcome back to another live stream. Okay, let me share the stream with other people on my Discord server. Please join my Discord server so you can get notified and you can vote on next streams. And also you can join VC on Discord. Like you can talk with me in live stream. You're welcome. And yeah, let me join the VC. Okay, great. And let's notify people live. YouTube. Discord. Okay, let me make sure everything is fine here. Right, seems good to me. All right, let's see. All right, so this is a very new kind of live streams that I'm starting right now, which is just me going through some challenges in codewars and just see how it goes, and possibly explain or teach you some Rust along the way, a bit of Rust, but we'll see how it goes. Anyways, let's get started, I think. Great, okay. So first challenge, this is a new account pretty much. Disembowel trolls. Okay, train. And let's see. Trolls are attacking your... Hello. Welcome to the live stream. Welcome back. How is it going? So, trolls are attacking your comment section. A common way to deal with this situation is to remove all of the vowels from the troll's comments, neutralizing the threats. Your task is to write a function that takes a string and return a new string with all vowels removed. For example, the string "this website is for losers" would become "the webs for losers." That's crazy. Okay, for this kata, why is it considered a vowel? I don't even know what is considered a vowel exactly. We'll see. All right, so here they have some Rust tests. Disembowel, this website is for losers, and the output basically should be this. Okay, let's see how it goes. So you take a stir reference, basically a slice to a string. It's kind of like you're just referring to some string. You're not like allocating, like you're not moving in a string or allocating a new string. And then here you're passing in a string. This is an actual allocated string basically. So yeah. Anyways, here it's implemented. Basically, we haven't implemented this yet. So all right, let's see how we can do this. All right, how to do this? That's gonna be interesting. Okay. This website is for losers. Okay, let me actually copy this into my IDE. And I do need the main function, or actually we could turn this into a lib.rs instead. So it's gonna be like a library. Okay. All right, great. Type mismatch, and let's see, inward disable. Let me disable these kind of weird stuff. Rename to disable inspection. Okay, what's up with this? All right, great. And let's see, so now we could basically say cargo test, and yeah, let's just make a little string here, I guess. String defaults, and yeah, let's try the test now. Cargo test. Oh, okay, so test failed, so we have to pass this test. Okay, so going to sleep, just want to wish you luck. Assalamu alaikum salam. Thank you for that, and have a good night. All right, so let's see. Okay, so let's see, iterator maybe. Let's why this doesn't give me an iterator? Interesting. Oh, it's already an iterator, I think. Okay, so we're gonna filter this. Why it's not? That's interesting. Trim left. Hold on a second. What? Raster. How do you get an iterator again? Not really. Can't believe I don't know how to do this. What? Hello Rio, how is it going? Thanks. Bro, how do you turn this into an iterator? What? Oh, I see. So yeah, I just remember. So in strings, instead of iter, you cannot do that. You have to be explicit and say chars. They removed it by, yeah, I just remembered right now. They have removed it intentionally because when you want to iterate over a string, like it could be code points. Like, do you want to iterate over code points of the string, or do you want to iterate over individual bytes of the string, or what exactly? So yeah, that's why they removed the iter method here. Seems like that's why I was super confused, because I didn't work with strings for some time now. But yeah, you have to either say .chars or maybe .bytes, or depending on what exactly you mean by iterating through the string. Because strings are pretty much very complex, you know. It's like, but anyway, let's, I guess, start with chars. I think they're gonna be Unicode chars, right? Over the chars of the string slice. Yeah, I think so. Anyways, let's see. So now we could filter it, and we're gonna filter it through, and we're gonna check if this is a val. I don't think there is a val here, stuff like that. Yeah, I don't think so. So we're just gonna use a match here. And finally, after that, we're gonna basically, can we say into here? Not really, doesn't seem like. So let's say collect, I believe. Okay, there you go. And here it's gonna say non-exhaustive patterns, type char is not empty. Okay, great. So now, what are the vals? Let's see. A. What else? O, I think. I. Is it? And E, I believe. A, E, I, O. A, E, I, O, U. Yeah, U. Right, and here, if it's a vowel, then we're basically, oh, we're gonna give it true. Actually, no, false, because we, hold on, because we don't want to keep it, right? And actually, yeah, I'm thinking that I'm programming in Zig right now for some reason. Yeah, so in Rust, it's like this. Or, so Rust match statement is very powerful. Hold on a second. Okay, so Rust match statements are very powerful, and this is one of the cases where you could just match on different things at once. So like here we're matching all of these. If one of these are the one, then we're gonna give false. Otherwise, you're gonna give true. In this case, does not cover all possible cases. Yeah, my bad. Here we're gonna say true. So basically, if it's one of these characters, then we're gonna go with false. Otherwise, we're gonna go with true. Let's try this out. And And what I've done here, oh, I see. So the O is actually uppercase. So I didn't include that. Okay. Let's say to lowercase, I believe. Like there's a lot of ways to go about this, but and this actually gives me an iterator. Interesting. You could tell that I don't have a lot of experience with strings. The eels map into the stars one or more characters. Yeah, fine, just say .next. This is basically about like strings being very complicated. Because like when you convert a character, like a UTF-8 character, I think, or a Unicode character, basically, if you convert it to lowercase, you possibly can get multiple characters or something like that. So this is why it's that complicated. But anyways, here I'm just taking the first character anyway and seeing what happens. So yeah, cargo test. And right now we're passing the test, so that's good. So basically, I have got an iterator over the Unicode characters of the string. Of course, I'm not owning the string. I don't own the memory of this string. I'm just taking a kind of like a view or a slice or like of some memory, like of the memory of the string, right? But I don't own the string. Here, I'm actually giving an owned string, an allocated string, a new string. Basically, here I'm just iterating through all the characters, and I'm filtering the character by if it's first of all, I'm actually taking the character and turning it into lowercase first. Though otherwise, if you don't want to turn this into lowercase, then you have to also include the case where it's going to be uppercase. So like you also have to say this, you know, stuff like that, and so on and on. So basically the uppercase versions too. But here I'm just going with this. Otherwise, there's another way we could do this, though I'm not sure how efficient that would be. But we could say A-E-I-O-U dot, and if it contains the character, and what's happening here, expected closure, found char. This guy expects a closure. Interesting. Contains is contained in what? Just anywhere in this string. Weird. I guess that contains maybe only takes in a string. Hold on, let me say cargo test here. Let's see, required by this bound in impulstor contains. Okay, and a lot of times you're gonna find that the compiler actually gives you the solution, which you can only find in Rust. So yeah. I see. So like when you get an iterator, it also adds like you're just taking references to the things, right? You're not taking the object itself. So here, instead of taking the character itself, I'm just taking a reference to the character. That's why I needed this dereference here. Doing that feels like we're doing Python. Yeah. All right, so this should also work. Of course, there's a lot of ways to solve this. And what's happening? Oh, I accidentally imported that. And it failed. Interesting. The other way around, I think. Yeah, I think. What? Yeah, I see. So I should either add A, E, O, I, O, U? No, hold on. A, E, I, O, U. Okay, something like that. And here you go, we have passed the test. Otherwise, what we could do to simply is just turn this guy into lowercase, take the next character, and there you go. So yeah, whichever you'd like. And we're gonna see also the solutions of other people. It probably could be much nicer than mine, since they're probably doing that for a long time. Anyways, let's see, attempt, and this should do the trick. Okay, so let's submit this. And yeah, let's see other people what they've done. Okay, come on. All right, so this guy done it kind of similar to me. He took a chars iterator, then we filtered over it, not that. And then here, instead of saying 2 lowercase, he basically said 2 ASCII lowercase. So he doesn't have to do that next thing. So he basically don't care about Unicode. And honestly, I didn't even care about Unicode myself, so I should have probably gone with this method instead for this case. Here, this guy have said s.replace. Yeah. Why? Okay, so basically replacing, if the string if any of these characters, then you're replacing it with nothing. Not too efficient, I guess, but that's pretty clever. Retain. Retain. I think retain is... Hold on. What is the difference between filter and retain? They're kind of similar, actually. Oh, I think retain basically does it in place. Yeah, it does it in place, retain. Retain, it's basically like filter, but it does it in place. But here we don't really need that. Here is basically allocating first. So you just turn it into a string, then he's doing that thing. But yeah, I mean, it works. Anyways. All right, let's just go to the next kata. All right, so duplicate encoder. The goal of this exercise is to convert a string to a new string, where each character in the new string is... Hold on, what? The goal of this exercise is to convert a string to a new string, where each character in the new string is this, if that character appears only once in the original string, or that if that character appears more than once in the original string. What? Ignore capitalization when determining if a character is duplicate. I haven't understood what they mean here yet. Let's see. Then, so you're getting this. Recede, you're getting... That's weird. So we're replacing the characters of the original string with one of these parameters, one of these parentheses. That's the first thing. Is if that character appears only once. I see. My bad. Gotcha. All right, let's see. So basically, if the character is unique in the string, we gotta replace it with opening parentheses. And if it's not unique, then we gotta go with a closing parentheses. Is that the case? Yeah, I think so. All right, so let's see how I can do this. That's gonna be interesting too. So word, I think word dodge. But no, we need the... I wanted to say map, but first we need the actual, like, to know if the character is already there or not. That's interesting. We could turn it into a set possibly, though I never used Rust set before. Let's see, hash set. That's probably like using a hammer just to like using a car to just hammer some nail, but okay. Let's see, this would help. No, I don't think. Let's just do the simple way. Let's just do it in a naive way for now. Let's say word. We probably want to count. Let's see str rust. Okay, let's see str rust here and see what kind of methods there is. Okay, so contains ends with find is ASCII. It's certainly like something like Python. Oh, fine. Chars. Let's see. Let me grab this first here. Ah man, let's go. Duplicate encode. So I'm gonna go with let's go with a hash map, fine. Let's go with a naive way for now. And let's see. Word.ASCII is ASCII. No, let's just go. We could go with bytes actually, but no. Let's go with chars, fine. And let's go with for each hash map, for each char, we're gonna go with hash map. Well, first I need to see if it already is there or not. So if it contains C. Then we're gonna say hash map. Well, actually, yeah. Let me use the entry stuff. Hold on. It's hash map the entry, and then I believe you give it the key, which is in this case char is basically C. And cannot borrow immutable. Well, this gotta be mutable, so we could actually change it. Here we're just creating a hash map, and of course, let's see, is this entry expected string? Let's just say to do here. Okay, so entry. Let's see what we got here. Insert entry. I don't really remember how hash map stuff works. The entry API I remember was very interesting. There you go. Yeah. Let's see. So entry and modify or okay, yeah. So you say hashmap.entry and modify. So if the entry exists, you're gonna get the. Oh, hold on, what I'm doing here? It's shouldn't. Interesting. Char. Counter. Yeah, that's exactly what I have here. So counter plus equal 1 or insert or default. Either or insert 0, or we could say or default to the immutable variable. And of course I'll just say this and this. And here we got, of course, we need to dereference this guy. And here we gotta tell it what kind of hash map this is. Well, I believe this would be usize. Expected type, try mismatch enclosure arguments. Okay, let's just do it here then. So we need char, comma usize, I believe. Is it like this? Doesn't seem like it. Okay, what about this then? Alright, great. And yeah, this is how you take the counts. Great. Let's just print this for a second. Hash. Or we could just use this. We could use dbg hash map. Let's see. Oh, no. Not or default, because the first time you get it, it shouldn't be 0, it should be 1. So, yeah. But found mutable size. Oh yeah, interesting, okay. And now this should give us 1, 1, 1. Okay, great. So what was the problem again? Let's see. So this, if that character appears only once, okay. But the thing is, we also have to keep the order of characters. Great. Loco for games, welcome to the live stream. How's it going? Okay, let's see. So now that we have the counts of the characters, though maybe I could use a tree, like a B tree map here, possibly. B tree map rust. There's probably an easier way. I guess I had too much sugar. Let's see. B tree map based on the B tree. I think a B tree map actually keeps the order of the entries, if I remember. Type inference, let's just submit. Okay. Yeah, I think a B tree map keeps the order, but a hash map doesn't, I believe. So let's, I guess, use a B tree map. There's also a B tree set. B tree set. Well, we only need to. That's interesting. Hold on a second. What about B tree set then? Yeah, actually B tree set would probably be better here. So we don't really need to know how much characters there is. We just need to know if they're duplicated. Hold on, no, hold on. No, not really. Never mind. Let's just go with B tree map. Okay. And what's up with this? Now let's import this guy. I don't need a hash map anymore. And let's see. So for count in counts, and here I'm gonna get the char and the usize, I believe. And let's go with the, well, Here's the char, and here's the count. Okay, great. And here, let's try to print the char. Let's see. Expected string. Come on. Yeah, I know. Come on. Okay. And let's see. What's up? Oh, what? Yeah, the to do, I cannot do it. Okay, fine. Let's say string new for now. And let's see. I just want to see the printing happening here. What's up with this? What? Char count. Expected found char. Which? Or you know what? Just do this. Let me change this guy. Let's say, yeah, okay. Let's do this. Ooh, what the in the world is happening here? I'm very confused right now. Okay. Okay, I see. This guy was confusing me anyways. So we got DIN111. Okay, great. Now let's go through all the characters for, I believe, char count, in counts, or in char, or whichever. Let's try now to print line char, and let's print the count just to make sure the order is correct. And let's go. Yeah, it's correct, right? But if I were to use a hash map, I think it wouldn't be correct. Is that the case? Let's import, just making sure. And yeah, as you can see, it doesn't keep the order here. All right, fine. Let's go back with B3 map. And now let's just do this. So counts for each. We don't really have to say for each, do we? Let's say map, I believe. Or like filter. Yeah, let's filter it first. And here we're gonna get the count and the char. And okay, so if char, like we're gonna check if count is, well, yeah, let's check if it's 0, I believe. Or actually, if it's, hold on, what I'm doing. No. If count is greater than 1, then give it this, else give it this. And actually map it, just map it, fine. And let's see, type char cannot be dereferenced. Oh, okay. And here, expected char found iter2. Which are you talking about? Collect. And let's remove this. Oh yeah, let's remove the semicolon from here. And yeah, counts. Why we're getting a, oh, I see. So this is the character and this is the count. Yeah, I think that should be it, maybe, if I'm not missing anything here. Actually, not really. This is crazy. Okay, the thing is, this wouldn't be good because yeah, it wouldn't be good. So let's go, actually, let's iterate over the word itself. And let's go chars here, and then map the char, and if let's see, if counts dot get right, and I'm gonna give it the key, which is char. And we're just gonna unwrap because we know for sure that it's gonna exist. So and what's happening here again? Mismatched types. Probably it's expecting something like this. Map in wrap is greater than 0. Expected U size. Huh. Okay, do this. And yeah, well, greater than 1. If it's greater than 1, we're gonna go with this, otherwise this. Yeah, I think maybe this is it, if I didn't miss anything. And here we got, oh, why the first one is should ignore case. Oh, I see. So, and modify. So where's char? And let's see, C entry C dot to ASCII lowercase. Okay. And also here, I believe, so ASCII lowercase, so char. And there you go. I don't think there's probably an easier way to do this, but let's see what the other solutions are. You can tell that I don't work with strings a lot. Anyways, let's see, tempt. All right. Yeah, let me grab the import here too. Attempt. Okay, great. So here's basically what I'm doing. So I'm having a word, right? And then I have a B tree map. I didn't use a hash map because I want the order to be the same. And the B-tree map have the key type as a char and the value type as usize. And here we're going through all the characters and we're getting the entry using the key, like the key would be the characters but in lowercase, so we don't care about the case, we ignore the case. And then if we find the key, then we basically modify it and add 1. Otherwise, we just insert 1 here. And after that, after we got all the counts, we go again through the whole thing, through all the chars, and then we map it to, so like if the counts of that specific character is greater than 1, that we map it to this character, otherwise this character. Let's see what other people have done, actually. All right. Let's go. Alrighty, there's some interesting solutions here. Okay, so this one is using a hash map. So for C, invert to lowercase chars, insert 0 plus equal 1. Okay. Word to lowercase dot chars dot map. So okay, but what about this one? Chars dot map. Okay, let's see this solution. So word.chars, and he's mapping the characters. So if word.matches C, word.matches C dot count, word to lowercase. What is matches here? Interesting. Let me grab this and let's put it here. This is my gigantic solution. Let's see. All right. Let's make sure that this passed. Yep, it does. Okay. So. An iterator over the disjoint matches of pattern within the given string slice. Hold on, I'm gonna get back in a sec. Okay, back. All right. So if it matches, the pattern can be a search char or a slice of chars, a function that determines if a character matches. I don't understand what this matches is for. So if it matches, so ABC. Oh. It gives a iterator over ABC. All right, it's numeric. And what you've done here is just give it the C. Oh, this is a what? Oh, because word is a string, then it gives us another string. I see now. Word dot matches C dot count. Oh, all right, I gotcha. Equal 1, and I don't think this is very efficient either, isn't it? Interesting. Okay, anyways, I see dot map. If lower dot find C equal lower or find C, he's basically trying to find the character in reverse. If they are equal, then this, else that. String from word to lowercase, s.chars map if s.find C equal r or s.r find. Yeah, I thought there would be like a much simpler and more efficient solution than what I've done. but turns out not that much. Interesting. Okay, next kata. All right, so check to see if a string has the same amount of x's and o's, the method must return a boolean and be case insensitive. The string can contain any character. Example, input and output. Okay, so you basically count how much o's and count how much x's, and if they're equal then say true, otherwise say false. Okay, and of course you gotta ignore the case. And yeah, all right, let's try this out. Should be pretty simple, I think. Let's go. So okay, let me copy this here. Great, let's go. All right, great. Let's see, so string dot, probably there's count. There's really no count. Interesting. But there was like a matches iterator here, right? Which actually gives us. All right, so it's actually efficient because I think it probably gives us string, isn't it? Yeah. Anyways, let's see the matches, and here we're gonna give it the x. Okay, I'm gonna give it x here. And for a second, let's just say true or whichever. So dot matches x dot count. So we're gonna count how much things in the iterator here of matching, and I believe we're just gonna say the same here, but for O. Though one thing that we're gonna take be careful of is that it should be case insensitive. So what we could do then is to turn it into lowercase, I believe. But this actually gives us a string. I don't want to allocate if not necessary. Okay, so what we could do then, hold on, what's happening here? Yeah, sure, let's just do this. Okay, so what about if we've done this then? Oopsies. Can we do this, by the way? No, cannot. Okay, fine. All right, so let's go with the closure. C. So if either C is equal to X or C is equal to X, basically, or otherwise we could say to lowercase, to ASCII lowercase is equal to X. And basically the same thing here, but for O. And yeah, type annotations needed. Interesting. Char. And here too, char. And this should possibly do the trick. Yep, there you go. Okay, that was simple. Let's see. Let's give it this guy here, and let's go. So attempt. All right. Submit. Okay. So s.matches x count equal s.matches. Okay, he's turned it into a lowercase first, but that actually goes ahead and allocates memory. It allocates a new string. I don't think my solution does that. Yeah, no, I don't think. So here we're just having an iterator called like of matches, and then we're counting the iterator. So yeah, we're not really doing any allocations. Here this guy is doing allocation when he turns it into a lowercase. Here dot fold, interesting. I could probably use reduce here maybe, but let's see, match C, a plus 1, and a minus 1. A is like the accumulator. Oh, I see. Accumulator. Interesting. So he's adding 1 to the accumulator. Yeah, I see. I wonder if you could use reduce here for this solution. I'm not sure. Let's see. No. No, you cannot, because basically reduce, you would assume that the accumulator would be a character. Okay, never mind. So all right, charts filter. Here this guy is using filter, which is also something, and honestly I think filter would have been much simpler maybe anyways. Not sure what is the difference here between match and filter. They're kind of the same here in this context. Anyways, let's go to the next challenge. Write a function persistent that takes in positive parameter. Finally, some numbers. Write a function persistence that takes in a positive parameter num and returns its multiplicative persistence. What? Which is the number of times we must multiply the digits in num until it reaches a single digit. Huh? Us multiply the digits in number until it reaches a single digit. So here he got 39, and you need to give it back 3, because 3 to the power of 3 times 9 equal 27. 3 times 9 equal 27. Oh. So they're basically multiplying this digit with this digit, and they get 27. Then they multiply each digit by the other digit, and here 2 times 7 equals 14. Then you get 1 times 4, and like the terminating condition of not doing this again is to basically get 1 digit. Yeah, I see. That's interesting. Because 4 is already a 1-digit number. Why you give it 0? Why not just 4? Oh, what? Why? Because 4 is already a 1-digit number. Okay, fine. Okay, let's try this out. Train. Alrighty. Finally, some numbers. Tired of strings already. Let's go. Okay. Let's see. Persistence 3, 9. All right. So, not sure if we could do this without allocating a string. Like we could just say num to string, but if we can do that without allocating a string, that would be nice. Let's see. Number, 39. We want to get the digits, right? We could, I guess, say, can we do this, by the way? No, let's just make our own, let's just shadow the variable so we could change it however we want. I'm gonna try to do this without allocating a string. I think allocating a string would be easy, but not too efficient here, I guess. So let's go with that, so I could make it mutable basically. Now let's see what we could do. Num equal to num. All right, so while num is less than 9, which means it's going to be like less than 10, which is going to be basically a 1 digit, right? So while the number is not 1 digit, essentially, what we're going to do. Okay, and then finally, I guess maybe we're going to give it back the number that we got after that. And here, what I'm going to say is probably... yeah, number So I guess I'm gonna take the digit probably like this, and then after that I'm just gonna divide by 10. And what else after that? And now interesting. Let me just see this print line real quick. Let's see this. Where it printed stuff. What? Didn't print anything? Oh, because the first number I guess is small or something. Left equal to right. So left is 39, so that should do it. I'm missing on something here. While number is less, oh my god, is greater than 9, I think. Yeah, okay. So I had it in reverse. Inverse. Okay, so we got digit 9. Digit 9. Yeah, there you go. We got 9. And then I think you're gonna have the number gonna be 3 after that. But no, we also want to get the 3, I believe. Yeah, okay, fine. Let's say print line. Oh, we already see it here. Left 4. Okay, so hold on. Where's the... Okay, so it got 39. Or is it? 39. Left equal right failed, right 0. Oh, it's actually doing it here. And it got 4. But it should get 0. Okay. And in that case... Alright, let's just do it this way. If num is less than 9, then I guess I'm just gonna return 0. Because it's kind of like an exception here, really. I think. Okay, got 9599. Why 5? Interesting. Assertion left equal right. Left 9. Left 9, right 4. Oh, my bad. Because the problem isn't just that, it's also multiplying the digits together. Ah, I see. Alright. Okay. So can I make a simple iterator to just turn some number into digits then? Or if that's not already there though. Hold on a second. I wonder if Rust have that yet. So num.digits. Yeah, that doesn't seem like the case. Interesting. So can we make a little iterator right now, possibly? I haven't created an iterator in a long time. Let's see. I think I remember, but yeah, okay, let's, I guess, try it. Struct digit iterator, I think. And number. u64 in this case, and impl, I believe, iterator for digit iterator, and then let's override the stuff there. Okay, so the item would be, it's gonna be a digit, so we could just go with UH, really. So, okay. And then option self item. And then here in the next function, we're gonna do something similar to this. So if number, if number, like it, let's have a boolean here, I guess, done, right? And basically if done, actually not really. Yeah, let me just do the core logic first here, and let's just say let digit, so we're gonna get the digit like this, self.num, and then afterwards we have to basically divide. Okay, self.num divide by 10. And then finally, we're gonna give it the digit. Okay, but some digit, right? Of course, as UH. Or, yeah, fine. Let's just go with U64, like just the same thing, right? Fine. Yeah, okay. Some digit, okay. And what else? What else? Now, what is the terminating condition here in the iterator? Which is gonna be if you divide by 10, it's gonna become 0, correct? I think. Yeah, I believe so. So then maybe if num self.num is equal to 0, then we're gonna return none, right? I think so. Yeah, maybe. Let's see. So let's create an iterator here, or let's just say 4-digit in digit iterator, and let's see. We could just implement new for this, like implement digit iterator fn new, and here you give it like some sort of number here, u64, and it gives you back digit iterator. It would basically just return for you digit iterator number. Right. Cannot find value num in this scope. Yeah, fine, call it that for now. And yeah, okay, so now we could say digit iterator new number. Let me just print this for a second, and let's see. Digit equal 9, digit equal 3, which is correct. Nice. There you go. I have actually printed 9 and 3. Great. So what we want here to do is to multiply these digits together. So what we could say here is digit iterator dot sum, dot product. Okay, what's after that? What we should do? Because 3 times 9 equals 27. Okay, fine. Let's see. So let number is equal to 0, I think. $39, because 3 times 9 equal to 27, and 2 times 7 equal 14. And if it's 4, because already a 1-digit number, well, let's just say this: if num is less than 10, then we're just gonna return 0. So we got this case out of the way. Otherwise, we're gonna take the product of this guy, and yeah, we're gonna turn this all again to a digit iterator. I see. So it's kind of like you're gonna turn this again into a digit iterator of the new number, and then you're gonna take the product again. I see. So let's make it num here, and it's gonna be mutable. Okay, and here while we haven't got a number that is less than 10, then we're gonna basically do num or number is equal to digit iterator that we have created, new. We're gonna give it the num and then the product of the iterator. Okay, great. And all of this just to not allocate strings. Let's see. All right, I think that seems to make sense. Okay, what I have left and right. Left 39. Oh, my bad. So if it's greater than 10, while the number is greater than 9, actually. It's greater than 9. Left 4, right 3. Which? Left 4, right 3. Okay, here. So for some reason it left 4. Why that's the case? Okay, can I see the whole thing on how it works out? Let's see. Debug. There you go. Okay. So this is what we're doing basically. We're getting 39 here. We're checking if it's less than 10, basically a digit. Of course it's not, so let's go forward. So here we got 39. We're checking if it's greater than 9, which means if it's not a digit. So if it's not a digit, then we're gonna make out of it an iterator. Then we're gonna take the product of the iterator, and then we get 27. 39. Yeah, 27. Right, correct. What's next? Then we take 14. Then we take 4. 14 then 4, which is correct, but what was wrong here? And 4 has only 1 digit. And then here we're sending back 4. Is that correct? But here it's saying it should be 3. What? Why 3 here? That doesn't make any sense. 1 times 4 equals 4, and 4 has only 1 digit, so you should return it, but here they're returning 3. This is stupid. Why? because 9. Yeah, I'm misunderstanding something here. Write a function that takes in positive number num and returns multiplicative persistence, which is the number of times you must multiply the digits. Oh, so like how much times you have multiplied. All right, so not the final number. Damn, okay. You must multiply until you reach a single digit. All right, so I gotta keep a counter. Great, fine. Let I is equal 0. And here let's just say I plus equal 1, I guess. And of course it should be a mutable variable. And then at the end of the day, we gotta give it the I, not the number. Okay. Let's try this out now. Okay. What? Interesting. Okay, fine. Alright, so we haven't allocated any string. We have just worked with raw numbers. Like, you just get a number, we create some iterator, of course, which is allocation free, and pretty much it's an abstraction that doesn't really cost any, like, what they call it even. I don't remember. Anyways, so basically what I'm doing here, I'm having this struct called digit iterator, which stores the number, basically the state of the iterator. Then I'm implementing digit iterator. I have a new function here, which it's just convenient, you know, just give it a number here, and it constructs a digit iterator struct, and it turns it back to you. Here we're implementing the iterator trait on the digit iterator, where the item is U64, though it doesn't have to be 64. We could probably go with any t that is a number. But then you have to constrain the t on a number, and then you have to use like a crate like num to do that actually. Let me just show you, although I don't think I'm gonna submit the generic one, because we probably cannot use libraries in there. Let's see, if we go to num traits, I believe it's called, if I remember. Yeah, num traits, okay. And here you could probably find the number trait or something like that. Check that, bounded. Okay, float and maybe also integer then. Modules integer. Okay, let's see. Generic trait for primitive integers. Okay, let's go. So primitive integer, this is a trait for, and it contains all these traits. So basically anything that is a number is contained in this trait, kind of. So but honestly, let me just show you. Fine. Cargo add num traits, so we could add the library. Wa alaikum salam. How's it going, gearing? And thank you, Local for Games, for the compliment. And prim int here. Let's see. So we could say t here, and we could say here t2. Implement t for digit iterator t, and of course here we gotta give it t again, and implement iterator for digit iterator t again, and here you're gonna type item is equal t. This is basically the type of the item that the iterator emits. Here we're just like referring to this item that is inside self, which is basically digit iterator. And then what else? And oh, actually you don't have to do this, you could just say self here. Okay, if self.num to type t. Okay, so we have to say is 0 or something like that, I think. Num equal to have we constrained that thing yet? I don't think we have done that. Hold on. Interesting. So generic programming is another adventure by its own, but let's see if I can figure this out. So yeah, like there's like, how would you check if some item is equal to 0, like, but it's generic, you don't know the type exactly. So we basically got to constrain the type here. Impl t, where t should be a number, basically, where t, or we could even just go with zeroed, possibly. Yeah, let's go with, it should basically be able to be a 0, like to have a 0. So then you could say t0, but then you also need to be able to compare these. All right. It should also implement equal, I think. EQ, or was it? I don't remember how you do this actually. Let's see. It's called iterator, or like not really iterator, generic bounds, I think. Rust generic bounds. Let me see. Let me see. Not really. Multiple bounds, right? How do you do? Oh yeah, the plus. I forgot. So you say this 0, and then I believe we could try EQ here. Okay, so right now we have added to generic equal. All right, cannot mod t by i32. Yeah. That's gonna be crazy. So right now you also gotta add to it the fact that you want to use a modulo operator. But then at that point it becomes crazy. Not sure how to go that wild, but the easy part here, like if it's just you want it to be a number, so you could just say num traits number. Actually here in this case we want it to be primary primitive integer. And yeah, that would possibly fix it. Expected type parameter t, found integer. Let's see what we got here. We could say 1 from b, from, is there like from here, I think, from 10 or something. Okay, I guess that maybe should work. And then here, this is basically 10. As you can see, generic programming is a bit more crazier. I honestly haven't done too much of it. Binary assignment operation cannot be applied to type t, which self.num. Is it like this maybe? Interesting, it doesn't contain that. It should be added. Anyway, so I guess maybe that's how you do it. And yeah, let's try this out. This is the generic, oopsies, the generic version of it. Oh, actually it works. Interesting. I haven't done generic programming for a while now. But there you go. So this digit iterator now works with any kind of t that is a primitive integer. That's very interesting. So here I said t0. Can I do like maybe 0? Oh, okay. So you could actually just say this. So if it's 0, then return none. There probably maybe a better way to do this one too. Not sure. I mean, you could do something like this. Hold on. Well, anyway, this is fine. This is fine. But I cannot use this in the test in the website because I cannot include libraries. So for now, let's just keep this as it was before we added generics, and let's just submit this with its iterator and stuff. Okay, let's see the other solutions. They're probably just gonna turn it into a string and just work on that. They're not as crazy as me, I guess, but we'll see. Tempt, sending requests, nice. Okay, what they have done. Yeah, this guy is pretty good, right? Yeah, pretty similar, but you haven't done like an iterator. You just done it directly, which is nice. There you go. Come on. Yeah, here you have allocated string. Nah. nah. Products. Again, allocating string. This one didn't allocate string. You've done it the Spartan way. Great. Here, allocating string again. Allocating string. Yeah. So, otherwise, how does actually... Okay, anyways, so it's kind of similar to my solution. Just that I have added the iterator. I've implemented the proper iterator. Okay, great. Let's go to the next one. Equal signs of an array. You are going to be given an array of integers. Your job is to take that array and find an index n, where the sum of the integers to the left of n is equal to the sum of the integers to the right of n. If there is no index that would make this happen, return -1. Returning -1 is not very rusty. It's not idiomatic Rust. In Rust, you shouldn't use sentinel values like -1. You should use option instead and just return either some number or like none. So that's just some side note. For example, let's say you are given the array. Your function will return the index 3 because at the third position the array, the sum of left side of the index 1, 2, 3, and the sum of the right side of the index 3, 2, 1 both equal 6. Index 3, 0, 2, 3. Interesting. Basically because this is equals to this because, well, they're just inversed. So let's look at another one. You're given the array 1, 150 and -51 and 1 and 1. A function will return the index 1. Here it's 1, and I would guess this would sum up to 1. Alrighty. Yes, I understand. Okay, let's see. Not sure how to start with this. Let's see. Let's just try to make a naive solution, I guess. Alright, let's remove this stuff. And let's grab the tests. And this is the test that we have. Actually, it's not using Sentinel. Okay. So the problem itself is using Sentinel, but the Rust version of the problem is using option, which is nice. Great. Okay. So let's see. Find. Why they're calling it even index? Interesting. But anyways. So for now, let's just give it a none. And let's see. How we're even gonna start with this? The easy way would probably be to just like now I'm learning web GPU. I see WGSL looks like Rust. Yeah, it is. It is indeed. And yeah, I do recommend web GPU, and especially, of course, WGPU. I didn't have a good experience with the Dawn implementation, but WGPU I recommend that, right? So, of course, in Rust, not the C++ version. Okay, great. So let's see, array length, because we need the index. Right, usize is not an iterator. Oh, my bad. So it's gonna be like this. This is basically a range in Rust. So from 0 to the array length, and let's see. Now if array let's see, if array up to I, from the start of the array up to I is dot sum, iterator dot sum is equal to same thing, but instead of 0, we're gonna go here with I. Though we don't want to start from the current index, we want to skip the current index, so I'm gonna say +1. There could be some other way that I'm not aware of in Rust. But anyways, and here we're gonna go with array.len again. So yeah, so if they're equal, then we're gonna return the current index, I believe. Expects the option usize but found usize. Yeah, here we're gonna say sum I. Otherwise, we're gonna return none, basically. Type annotations needed. Okay, so this sum you gotta give it like what kind of type you're expecting, I think. And let's go with usize, I believe. Would that work? Value if you cannot be made by some iterator of elements of type I32. Oh, okay. Can I do into iter here? That work? No, that doesn't really change much here. Let's say copied, okay? Because iterator basically I think gives the references. So, oh yeah. And the thing is, this arrays of I32s, yeah, makes sense. But what if I say this now? Oh, okay, gotcha. So it should be I32 here, and here, same thing, though it seems to be just, but like, can't I just do this? No, doesn't seem like, but, why allowed this to not have that? Like, what? That seems inconsistent. Oh, I guess because like it's inferred from the fact that they can be equal. Okay. So I guess this should possibly work. Let's see, debug. Really? Did it really work out from the first try? Interesting. Okay. Great. So is there some way we could actually make this better? Some way we could make this better. I can't really think of one right now. Iterator sum. Fine. Let's just submit this and see the other answers. It would be interesting. Oops. I'm always curious to see the other answers. Attempt. Let's see. Okay, great. So let me just explain a bit here what I've done. So of course we're just, looping through all the array indices. So like from 0 to the array length. And then we're checking if the first portion of the array from the left side of the index, of course we're taking the iterator of that slice, then we're summing it up. So we're summing all the elements in that portion of the array. And of course we're summing it into this type, I32. Then we're checking if that equals to the sum of the right portion here that we're doing here. So we're just saying I plus 1, because we don't want to include the index that we're currently in, and that's not included in the sum of the right part, neither the left part. And that's why I'm adding +1. And here up to the end of the array. I'm not sure if I could do this. Can I? Yeah, I can, seems like. So I didn't need that. Okay, great. And then here I'm iterating over it and getting the sum of that. And if they're equal, I'm just returning the sum. Okay, great. So let's just go with this now, attempt, and let's see the other solutions. That would be interesting. All right, what's up? Find even index. Let mutable r, mutable l, array iter sum. There you go. What I'm doing. Comma 0. Okay, so L is equal 0. Okay, good. For I, N in iterator, iterate, enumerate. Okay, so he's getting iterator, then he's saying enumerate so we can get the index, not just the item by itself. And then R minus equal N. Oh, why we're taking this? Oh. Really? Hold on. R minus equal to N, and if R equal L, return some I. That's pretty clever. That's interesting. I guess that's probably more efficient than mine, because what I'm doing right now, I'm actually summing, like every time I'm summing the right portion, here what we have, what he have done or she have done or whatever, like they took a sum of all the elements, then they have iterated through all the array, and then they keep on, subtracting from the actual like sum of the whole array the number. And if they're equal, that means that they're actually, well, the two sides are equal. We have found the index that we want. That's very clever, interesting. So like here, he have only done like, yeah, one sum pretty much, and then just subsequent minuses. Yeah, that's pretty clever and pretty cool, actually. 0 to length. Position. This iterator basically returns the index that you have returned true to, I think, if I remember. Let's try to see what's happening here. Oh, he have renamed this, okay. And this iterator searches for an element in an iterator, returning its index. Yeah, exactly. So you give it a predicate closure, and then you give it true if you want that element, and if you give it true at that point, it's going to return the index that you are currently in currently. So yeah, position I iter some, yeah, very similar to my solution, although he's used this. It's more rusty, I guess. yeah, more rusty. It's basically the same thing, right? That's very cool. That's very cool. I love this. Yes. All right. What else? Okay. Anyways, let's go to the next one. Array diff. Your goal in this kata is to implement difference function which subtracts one list from another and return the result. Should remove all values from a list A which are present in list B, keeping their order. Okay. Array diff vec1 2 vec1, it returns vec2. Okay. If a value is present in B, of its occurrences must be removed from the other. All of its occurrences. Oh, okay. So it's not as simple as I thought to some degree, but okay. So 1 2 2 2 3 pick 1 3. Oh, great. That's interesting. Let's make another naive implementation. Let's see. All right. Partial EQ. Oh, this is actually generic. Yikes. Oh, it's fine. We're not doing any kind of operations on it, so that's fine. All right. Let's see. Vecti there. Great. Let's see. So should we remove from the A or the B? Yeah, seems like the A, and then you return the A. Okay. Check. So we have a remove function here, but this just removes one element at some index. No, that's not what we want. And then we chain immutable specified by the predicate. Okay. But it doesn't really have to be mutable. Rechain. Yeah, I think maybe we want rechain here. Though it's not going to be very, very efficient, I think, but let's see. X or whichever. And then, oh, cannot borrow immutable local variable A as mutable. Can I make this mutable? Not sure. Then let's say if B contains X, then retain it. Mismatch types, and then just return back A, I guess. What return actually returns? It returns nothing, I guess. Yeah, seems like. Actually, it returns a boolean. Okay, great. It returns a boolean. What is that boolean though? Returns false. For, in other words, remove all elements. Anyways, let's see if this actually works. It have failed. Why? Left 1 and right 2. Right 2. So this one you have failed. Okay, so we have returned 1 for some reason. Oh, it should probably be the actual opposite. So not B contains, I think. Let's see. And yeah, there you go. So as simple as this, pretty much. So retain is basically like filter, but it's in place. So yeah, simple as that. Though contains is a bit not too efficient, at least in terms of big vectors, because it's gonna do probably a linear search, I think. But yeah. Yeah, let's just submit and see what other people have done. I would guess same thing. Let's see. So yeah, one person have done the exact same thing. Into iterator, one dot filter. Okay. The problem with this is that you're gonna be basically allocating a new iterator, a new vector. Just use A. So just like mutate A, but yeah, I guess functional style people would like this. Anyways, hash set, why? Oh, not really needed. Wasn't needed. Okay, so nothing very interesting in this one. It was pretty simple. So let's go to the next one, I guess. Create a phone number. Write a function that accepts an array of 10 integers between 0 and 9 that returns a string of those numbers in the form of a phone number. So you get a slice that contains some digits of phone number, then you gotta format it like that. Okay. Return format must be correct in order to complete this challenge. Right. Okay. I guess they should be pretty simple. But let's see. And we gotta allocate a new string ourselves. Okay. So the easiest approach would basically to use format here and to just like where's the format that we need? Yeah, it's right here. Okay, and to basically do something like this, right? And to do something like this. This is like the most straightforward approach to do this. And to just say numbers 0, numbers 1, and you got the point. But you're so lazy to do that. Let's see some other way of doing this. So right, number is equal to numbers. Let's get the first 3 digits up to 0 to 3, and then let's just turn that into a string, I believe. Do we really have to now? Hold on. So this would actually give us an array, a slice actually. Okay. Actually, I think what I'm gonna do, create a new string, I believe, and I know that this string would take this much count. So like 1, 2, like here we got 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 14. So we could say new, well, is it called reserve, I think? Yeah, 14. But no, how do you create a new, yeah, new with capacity, right? So let's go with 14 capacity, so we don't have to reallocate every time. We already know what the final string would be like. And now what we could too simply say, I guess, number, or maybe you could use the right, if I remember. Don't remember how they use this though. Requires at least a format string argument. Yeah, I don't remember how they use this. Let's see. Didn't use it for a long time. Not really the macro, I'm talking about the macro here. Yeah, there you go. So you give it a mutable. Okay, nice. So mutable number, then you basically say this, and in my case it's gonna be something like this, I believe, and then number 0, 3. Cannot write into mutable string because it's not mutable, I believe. What's up? Cannot be known at compilation time. Huh. Cannot write into mutable string. Why? Weird. Well, honestly, we could indeed just say format, I think, then. But no, that would actually... Hold on, go back. Can we say this? Numbers 0 up to 3, I believe. Doesn't implement CDFNG display. What? U8. Oh, because they're digits. U8. Yeah, it's not a string. Oh, I see. It's not a string, it's actually digits. I see. Makes sense now. So yeah, we have to go with that way. And here, yeah, I thought I had a slice of strings. Interesting. I mean, I could just say this, you know. Is it? Cannot write into mutable string. That must be used. Well, no. Let's just say maybe folder. Oh yeah, join. We could try to find something like join here. But no, these are numbers. Over the chars of a string slice. That's interesting. Why cannot write into a mutable string? What the? Let mutable number. Weird. I guess maybe I need this. Exists for mutable reference mutable, but its straight bounds were not satisfied. Which? Okay, fine. Let's just say this. Let's just say 4 digits in, or let's say number or slice. Yeah. From 0, oopsies, from 0 to 3 dot for each push dot chars. Can we say this number dot extend, I guess? Is not an iterator. Oh. What about this? Not really. Oh, so it's actually a string. What? Sir is not an iterator. Weird. This is crazy. Alright, anyways. Dot for each. Fine. Go with digit in this. And just say number. Oops. Yeah, they are bytes. So what's up with this? No field is. I'm confused right now. Why this is not an iterator? That's crazy. Expected string, but found char. Yeah. Oh yeah, let's push. Cannot borrow. Okay. Okay, I see. I see what I was gonna do here. I was gonna mutate the string while I'm actually iterating over it. There you go. That should never happen. Alright, so that's interesting. Yeah, I actually got a... Oh, I thought I was iterating through numbers, not number. That's... Damn. That's what confused me here. Stupid. Fine. That is another level. Let's just say this. Yeah, there you go. Okay, so that was what was confusing me here, basically, because I thought I was working with this while I was working with... Damn. Anyways, expected char but found U8. Expected char... it's kind of similar. Not too similar. I mean, char is a Unicode, I guess. But anyways, so number push digit as char. But before that, I actually gotta push. Could it be why right didn't work? But anyways, let's just do it the naive way. So let's push, and we're gonna push. We're gonna push this. So. And we're gonna push this. And oh, now I think I could probably do something like numbers. Let's map it first. I guess we could call this digit and then digit as char. And of course we gotta do this. Otherwise we could also probably say don't copy it instead. Yes, and then yeah, and then yeah, can we actually just say string plus that? No, of course not. Okay, the extend then. Would this also work by any chance? Let's see. And that doesn't look happy. Number extend. It's not an iterator. What in the world? So what is it? Yeah, I'm falling into the same trap again. Damn. Fine, anyways, never mind. Go back. Oh, am I using the wrong thing here? Again. Numbers. This is super weird. Anyways, I should just focus on making this work at this point. Missing. Oh yeah, I see. In numbers dot push digit. Why this got removed? Okay, and then here I should. Yeah, here I would like to say this. Weird. Okay, fine. Seems like I'm not using Python. Okay, let's go. And push stir, I think. Okay. Yeah, there you go. Alright, so like this. And then what else? We could probably make this into an iterator. But let's just make this work first, honestly, at this point. And let's go with 3 here, and then, well, I guess 6. Yeah. Then we're gonna push all that, and then finally number, well, not finally, but anyways, number this. And welcome to the stream, Pyre. Welcome. Number. Yeah, and finally we're gonna have this. This like that, and then 6 here. This would probably work out if I didn't miss anything, which I probably did here. And oh, what is that? You won? What in the world? With capacity. Which digit as char? This is another level. You're pushing the Unicode value. What? Hold on. But yeah, I have to push the Unicode value. It's the character itself. What's happening here? You're pushing 3 rather than 3. Oh, yeah, that's correct. Okay, I see. I see. Can we do this little trick right here that I usually do in C? It doesn't seem like. No, add char to char. Okay, so this is not C. I think char for me. Yeah, that's true. Char. Digit as. Yeah, actually just digit, and really from U8, I think. And never mind. Let's just do this. From U8. You can actually give it from digit. Interesting, okay. And then the radix is 10. So what now? Okay, so this could like, I guess, fail or something. Panics if a given, returning none when the input is not a digit. Okay. Type expected U32 but found U8. Add save cast. Can I say into here or not really? Okay, fine. That's pretty much it. And okay, finally. Oh my god. Let's see. To probably fine if you remove the deref. The deref. Not really. Yeah, no. Okay. So is there a better way to do this? So I tried to use an iterator here before, but it didn't work out so well. So it's basically trying to do number extend, but I guess basically I was, oh, hold on. So if I say extend, and then dot map, I think you can use numbers dot char dot skip dot take 3. Yeah, I see what you have done there. I think slice here is fine, 0 to 3. But honestly, yeah, I think it would be nicer to just like make an iterator first. So like maybe do this and turn this into an iterator, I believe. And then we could just like say iterator. But then how would you make sure that it only calls the iterator 3 times here? It needs to be mute, yeah. I guess you say iter.take. Is it? Create an iterator that yields the first n elements, which is behind a shared reference. Well, I'd like to only advance it 3 times. Oh, all right, that's cool. So now I could say iterator.take, and then here again iterator take 3, and then iterator use of moved value. Can clone the value and consume it, but it not be. Yeah. Why take is consuming it? Should I do iterator again? Not really clone, because if you clone it, it wouldn't work, because like, yeah, it wouldn't work, because I'd like to basically consume 3 times this, and then 3 times here again, but like not start from scratch, start from where I left off. So ref mute iter. Yeah, let's just keep it like this and see the other people's solutions anyway. I think I've spent a lot of time on this already. Maybe it won't live long enough. Yeah. Okay, let's just keep it as it was for now. And let's just go ahead and see what other people have done for this. So, yeah, let's grab this. Attempt. Submit. Let's see. What are the other solutions? People create the wildest solution, that's for sure. Okay, so this is what I was kind of trying to do, but I'm not sure what happened that it didn't work for me. The thing that was really kind of confusing me is that I named them the same thing. Like this, I named it number and here numbers, which very confused me. I should have not done that, but yeah, I was kind of trying to go for this kind of solution, but something wasn't working. But anyways, numbers into iter dot map what, why? Damn, he's creating a new string for every single digit? No way. Yeah, there you go. That's interesting. I'm not sure why. Anyways, there you go. That's the solution I told you about. Okay, string iterator map the wildest solution. Yeah, I was shooting for this one, but it didn't work out for some reason. Anyways. So what's up here? Okay, finally some good solution here. So he's iterating through it, mapping it to from digit in wrap and then collect. But then why are you using another format? Oh no, I think mine is probably much more efficient. Anyways. Because here they're like allocating twice, once in the format and once here. This one at least is allocating once, but I'm not sure about the efficiency of this. Well, it works. There you go. Fold. Stringify. No, this also allocates twice. Interesting. And it's also probably not like reserving for the allocation too. This one again allocating twice. So yeah, I guess maybe my solution up to this point is best, because I'm like creating one single allocation, one string, and I'm not even reallocating. I'm making sure it's not reallocating by giving it enough capacity, which is 24 bytes per string. What do you mean? And then number dot push that, and yeah, I think it's pretty efficient, honestly. But let's go to the next kata. I shouldn't spend too much time on that one. Counting duplicates. Count the number of duplicates. Write a function that will return the count of distinct, case insensitive alphabetic characters and numeric digits that occur more than once in the input string. The input string can be assumed to contain only alphabets, both uppercase and lowercase, and numeric digits. No characters repeat more than once. A and B. Distinct. What? will return the count of distinct case-insensitive alphabetic characters and numeric digits that occur more than once in the input string. No characters repeats more than once, okay? A and B. So here you got 2. A occurs twice and B twice. B and B. I occurs 6 times. I'm not sure I understand this. I mean, I understand the fact that you have like the repeated ones, but the count. Like, is it the maximum of repeated characters count or what? Well, what kind of count? I mean, what happens when there's 2 things that repeats? This doesn't make sense. How many characters appear more than once? Like, for example, here, A and B. Oh. I see. Kind of stupid. Anyways, let's go to training. Okay. Let's see. So basically, how much things are repeating. Okay. Count duplicates. You don't need this. And let's grab this. And let's see. Your code goes here. Alright. Count duplicate. Where to even start with this? We could start with a naive implementation with the hash map, I think. Actually, we could try to use hash set here. Or is it? No, not really. Yeah, no. That wouldn't work. But that would just give you like the unique stuff, not really. A and B each occur twice. Yeah, let's just go, I think, with hash map probably here. Let's say counts is equal to hash map new, and this hash map would basically contain, well, we're gonna go through the whole string, right? So text dot chars, yeah. But is it case sensitive or no? Case insensitive, I guess. So we could say to ASCII lowercase, I guess. No, this would give us a string. No. Let's go with an iterator, or let's like, yeah, let's just get a chars here. Let's say to, we cannot do that, interesting. Map then. To ASCII lowercase. And then what else? Okay, counts dot entry. The key here is C. And this needs to be mutable. Great. So insert, actually, and modify, just like before, really. And modify, we're gonna say here, this would give us the count, right? And here we're gonna say count plus equal 1, or insert 1. I think so. What's up? Okay, great. Now we get the counts, and so we gotta basically, I guess, say counts dot filter count equal to 1, I think. Okay, and then we get the count of this. But found use size, fine, go with U32 here. Count, I see. Oh, I see. Count dot 1. Oh yeah, I see. And here we could say this. Here I don't need the char, don't I? I think so. And yeah. Okay, left 8, right 1. Oh, interesting. Interesting. Can we do this here too? That's nice. I knew that, but I kind of forgot about that completely. Alright. So for some reason we're giving it H. And it's telling us that there's only 1. Oh, should it? I see. There you go. That's basically it. I wonder if there's a more efficient way than this. I would guess so, but yeah, let's see other people's solutions. What the? Oh yeah, I need the import here. Let's grab that and let's go. Submit your final kata solution. And let's see what's happening here. Yeah, hash map, there you go. Really wonder if there's a more efficient solution. C to 2 lowercase chars or default E plus equal 1. Okay. Values. So I guess I could have done values. Ah, alright, that's nice. And I guess like this. Right, nice. What else? This one, what he's doing? Text to lowercase. Well, he's allocating a string here. But well, we're also making a whole hash map, so yeah, that probably allocating string would be nicer. So, anyways, chars counts. Ooh, dot values dot filter. Don't count. Iter tool. Oh, okay. Yeah, I'm very interested into this iter tools actually. Very, very interested into this iter tools. I always wanted to learn it. Well, it's in Rust, of course. It's Rust great. It's very interesting. It gives you like a lot of cool iterators. And well, let me actually see. Hold on a second. Where I was here. Let's just grab this guy here. Let's see his solution. So we don't need a hash map. But here he's using counts, which maybe makes a hash map. Well, that's interesting. Okay, I wonder if this actually allocates or not. Let's see. Okay, I gotta import. Was up, Manana? What? Welcome, DG. How's it going? Let's see. You have so much respect for me. Oh my god, thank you so much. Let's see. Thanks so much. Cargo. Test. Okay, passed. Okay, well, what does counts actually do? There you go. It's creating a hash map. Alright, so there's not really a lot of interesting. So there you go. It's creating a hash map. I love your every content. Thank you so much, DG. Welcome. So yeah, there you go. It's creating a hash map, and here he's also allocating a string to make it into a lowercase. But I don't think he had to do this. Yeah, he didn't really have to do this. Like, he could just say the chars and then like, it's weird that the standard library doesn't give you this as an iterator. But anyway, map C, then just two lowercase here. Yeah, basically. And now you don't have to allocate a new string. So just the hash map. So this is pretty good. Pretty good. Pretty good. Love this. Okay. Though what he have done counts. Yeah, okay. Values filter I greater than 1 and the count. Great, I love that. Yeah, I wonder if there's someone who have actually managed to not use something like a hash map. Yeah, I wonder if it is possible even without something like a hash map or something similar, like some sort of allocation or whatever. Oh, he's like creating a static array because he knows that there will only be characters there. Yeah, I mean, in the problem they said that. That's interesting. Okay, so there you go. I think he didn't allocate here. I think so. I mean, I don't see anything that would allocate here. Yeah, this seems like it doesn't allocate. He's using an array, a static array here. So that's very nice. Probably same thing here, seems like. All right, that's interesting. Okay. But yeah. All right, let's go to the next one. Directions reduction. Wants a fair but a clean one-liner. Yeah, this is one very good, honestly. That's lovely. The only problem that was with his solution was the fact that he's like using two lowercase, which allocates a new string, but just adding this map C to ASCII lowercase, there you go. Perfect solution. Once upon a time when I went through the old Mountains West, I hate these problems that needs to make us like a whole story and stuff. Anyways, a man was giving directions To go from one point to another, the direction were north, west, east, clearly north and south, and opposite west and east too. Go into one direction, coming back the opposite direction right away is a needless effort, since this is the Wild West with dreadful weather and not much water support to save yourself some energy, otherwise you might die of thirst. Following, depending on the language. Okay. You can immediately see that's going north, and immediately south is not reasonable. Better stay to the same place. So the task is to give... Come on, bro. Just tell me the problem. So the task is to give the men simplified version of the plan. A better plan in this case is simply west or west or west. Just unify. Other examples in... Oh, I see. Come on, it's a very easy, like, simple problem, and you have to make this whole damn story about it. Come on. Anyways, never mind. Let's see. So if I understand this correctly, basically we're given like a lot of directions, but they're redundant, kind of. So you have to basically reduce it to only the needed directions. I think that's pretty simple actually, but let's see. Oopsies. Let's see. And I'd like to keep this editor tools, honestly. That would be nice. Let's see. The reduce. And let's get the tests too here. Though it's nice to refresh myself a bit on Rust on such simple things. De-reduce. Although, for example, like this, strings, honestly, for my own stuff, I don't really work with strings too much, so, but anyways, vague direction, okay, so I gotta give it a vector, and here we're getting a slice of directions. Okay, great. North, east, south. Okay. So can we count stuff? Let's see. Dept. Well, honestly, I'm just gonna say this. I believe maybe X and Y, and then we could try to say for direction in directions. Here, let's just say to do or something so it doesn't. Anyways, direction. Okay. Now basically match the direction. And basically if the direction is, oh, okay, well, if the direction is north, then go with, I don't know, I guess 1 maybe. Yeah, well, let's go with 0 1 maybe, and then like X Y does not cover all possible cases. Let's just do this first. Direction east. East, let's give it 1 0, I guess. Direction west. West. and the direction south. Invalid left hand side, so we cannot do such shenanigans in Rust. Interesting. Binary assignment cannot be applied to type I32. Okay. Okay. So well, it would have been nice if this worked. Okay, fine. Let's just do this then. Can I say maybe then at least here? Yeah, that doesn't work. Okay, fine. Let's just say this. Y plus equal 1. And I guess x plus equal 1. And here x minus equal 1 and y minus equal 1. So basically I'm translating this into kind of like a vector, basically. And at the end of the day, you're gonna have that vector, like whatever you keep adding the vectors, it would end up at the end of the day at from point A to point B. So that's the idea here, I think. And now after that, we're gonna give it a vector of directions. Okay, great. So we gotta create a vector. Alrighty, so how are we gonna do this? Well, let's say well, again, it depends though. Like if the x is negative or positive. Interesting. Let's just make directions vector. Anyways, vic new for I guess in or actually we could, by the way, allocate like with capacity maybe. Like we know there would surely be absolute value of x plus absolute value of y. Yes. So x dot absolute value plus, I believe so. That's gonna be how much directions we're gonna have here. Expected use size but found I8. Type mismatch. You must specify type for this binding like I32. Ooh, what? Well, let's say I size just to be safe. Okay. Great. Now we got directions vector. Now let's just push stuff in. So basically it depends if x is negative or positive. So if x is negative, then we're basically gonna go through for like 0, well, for I or whatever in 0 to absolute value of x, we're gonna basically go ahead and add directions. So directions dot push. So here it's -0, So we gotta go with well, like less than 0x, which is gonna be west, direction west. So direction west. Well, this is gonna be mutable, of course. Okay. And all right, else same thing, though we know for sure we don't need the absolute. In fact, even here we could just say minus, really. Yeah. And by the way, here let's just give it directions, and yeah. And then basically kind of similar thing to the y. Okay, there's probably a nicer way to write this, but we'll see. Minus y direction. Well, we have assigned that south. Here north. I guess duplicated code. Who cares? And let's see. Failed. So the left is probably my answer. Yes, it is my answer, which we didn't give anything. Interesting. And the right is north, west, south, east. Northwest, southeast. What I'm missing here? Well, let's see what the algorithm is doing here. Let's say maybe possibly here. And let's go. All right. So we got x minus 1. And so it would give 1, which is y 0 for some reason. Well, that's right. That's correct. Okay. And what about here then? Here we got x equals 0 and y equals 0. Huh, why? North, west, south, which is correct. What? Hold on a second, what? They wanted us to reduce the thing, so what's happening here? I'm confused. The thing is, if you give me north, west, south, east, north would cancel out south, and west would cancel out east. So why? This doesn't make any sense. Weird. Am I missing something here? Yeah, probably missing something here. Oh. Probably missing something here. Yeah. But this doesn't make sense to me. I mean, the algorithm, at least from my understanding, is doing the right job that I was that I wanted it to do, but what's happening here? Let me read the question again. Hold on. Where is the problem again? Instructions. I think I understand what's happening here. Yeah, I guess basically what's happening here is that in this problem at least, you're only allowed to cancel them out if they're like consecutive, isn't it? Yeah, if they're consecutive. Yeah, but that doesn't make sense, does it? It's like the direction would just add up and they would just cancel each other out, like. But yeah, for the problem seems like we gotta make it to be consecutive. If they're consecutive, then we gotta basically cancel them out. So yeah, well, I think we gotta change a lot of things right now. North, east, west, south. Okay. Maybe I have an idea on how to do this. Let's see. Array. Well, let's say old direction, new direction in array, no, Windows 2, I guess, if I understand the problem correctly. I'm not really sure. Expected direction, but found that. Oh, is it like this? Oh, interesting. Okay. And then basically, well, we're gonna create new directions, and I'm gonna make it just like with capacity of the array itself, because that's the maximum length it can reach, though it probably gonna be smaller. But anyways, here's directions though. Well, basically if old direction, well, let's actually switch, I guess. Well, match old direction. So like if it's south, actually it's match on both, I believe. I'm not sure. Let's see, and of course here let's just return the directions. Does not cover all possible cases, correct? The IDE is super useful. Okay, so the old direction now. Let's see. So if direction is north, and the new direction is south, then we basically gotta cancel those out. Or if the direction is, well, it also works in reverse, I believe. West. Or if it's, yeah, it also works in reverse though. So let's go ahead and say this. but we basically gonna flip them. Okay. Great. And now, non-exhaustive patterns. Well, if it is one of these guys, one of these patterns, then we basically gonna have, or otherwise, well, basically here we're gonna skip, like, yeah, otherwise, well, if it's other than this, then it's gonna basically be, I believe, equal. Not really, not necessarily, yeah. Oh, I see. Anyways, so if it's other than this, well, we're just gonna capture these directions, I guess. So directions dot push, push the old direction and push the new direction, I guess. Push. I'm very curious about the the solutions of other people with this. That's interesting. I'm probably overthinking it and overcomplicating it, maybe. But anyways, skip. Now here, of course, we're not doing anything essentially, so we could possibly use retain here. Not really. We're using array.windows here. And .windows is like, it's kind of like just taking 2 items at a time from the array and just like going step by step. Like it would go at first, old direction and new direction indices would be like this. So 0, 1, and then 1, 0. Hold on, let me just fire up some simple editor like Cage here real quick. So like at first it would be 0, 1 indices, like the first item in the second, then it would be 1, 2, then it would be 2, 3, and so on. This is Windows 2. If it's Windows 1, like Windows 3, for example, it would be 1, 2, 3, then 2, 3, 4, then 3, 4, 5, and so on. But anyways, so let's see if this actually works by any chance. Expected vec direction but found direction. I see. Can't we just clone these or something? Not really clone, but copy it. I guess. Not really. Yeah, no. Yeah, no. Let's just go with this old direction, new direction. Copy it. It's trivially copyable. So, and refutable pattern in for loop bounding. What? I guess maybe I need this. Right. Couldn't we solve this problem by sorting the list and removing pairs? Sorting the list. You can't really sort the list because direction doesn't derive comparison. So the direction cannot be dereferenced. Oh, it's already. So why it was complaining? What? I'm confused. Okay, what? Array.windows. Hold on, let's check this guy here. So okay, can you give me the link? Let's see. Well, I guess let's just do this then. Let's just, I don't know, say something like this, and let's just say this, or something like that. I don't know. Let's go with this. Well, I guess this seems to work out. Maybe because the Windows doesn't encode in the size of the slice that it's inputting. Weird. Anyways, cargo test. Match, push. So, left, right. Oh, what? So south, north, east, west, west, east. What is wrong with this? Yeah, I really don't understand this stupid problem. Like, doesn't make any sense to me. Let's just see the people attempts. I guess skip. Fine. I don't want to waste too much time on this. What? Oh, it doesn't show the damn. Can I go back? I want to see the solutions. I guess you cannot. Yeah, adjacent directions. That's what I missed. Even when I've done that, now it doesn't work. Anyways, who cares? Go back. Just skip this one. Anyways, let's see the next one. Complete the solution so that the function will break up camel casing using this. Oh my god. Okay. Complete the solution so that the function will break up camel casing using the space between words. Okay. Okay. I hate string manipulation. Fine. Let's see. Solution. And let's go. So, camel casing identifier. Okay, let's see. So I'm gonna scan through and find the first letter that is uppercase and insert a space before it. Yeah, I think so. We're getting an str, so we gotta allocate anyways. Okay, camel casing. Okay, let's see. So s dot find. By the way, what are your thoughts on Zig after having used it? I think it's really great C-lang replacement. Exactly what you have said. I would use Zig instead of things like that I would use C for, basically. And anything else I would use Rust. So, yeah. Find or find. Let's go. Though even then, like, Zig is still very in its infancy. So like the build system is very annoying. Like if you're gonna be working on Zig currently, it's like you gotta be prepared to just do most of the things yourself. What I really love about Rust, and that Zig doesn't have yet, is like the ecosystem is very like coherent, I guess, and consistent. Like for example, let's say you want serialization and deserialization, right? Then, well, you're just gonna go with Serde. Like any library that you're gonna install is probably gonna have support for Serde, and just you install Serde, and yeah, like suddenly all your libraries have that. Also, the documentation is also very consistent among all libraries. The style itself, thanks to Rust FMT, it's also consistent. So the documentation is always there, or at least most of the time. What else? And you could probably find the libraries that you want. And also, of course, well, to add the library in Rust, you just gotta say cargo add, and there you go, done. In Zig, it's crazy. But yeah, though I would expect it to be better in the future. So right now, but the language itself, it really have a lot of cool features, especially the error defer, things like these, and also the fact that it's like having allocators as explicit. Like I haven't really thought about allocators before until I actually used Zig. The other thing is about Zig that I like is, yeah, of course, the comp time stuff, like being able to just like, for example, the thing is, for example, let's say this is something that I wanted just today, which is basically, let's say you want to have like some sort of an enum, I don't know, let's say some enum x, whatever, and let's say you want I'm not sure what to call this. Anyways, let's just say A, and this is gonna be generic. Let's say some T, and A, like variant A and of T, which is gonna hold a T. And then B, I don't want it to hold a T, but I want to hold some integer, or not even an integer, just an array actually. Just an array, let's say U8s of the size of T. So basically a bit field in the size of that T. So std mem size of, and yeah, something like this. But it isn't possible currently with Rust, though I think it would be added. But yeah, this is one thing that I wanted to do just today, but I couldn't do. Generic parameters may not be used in const operations. There you go. Use feature generic const express. Even though when I used it, I believe it didn't work out still. Yeah, and it gives me this unconstrained generic constant, which I have no idea what it's talking about. Like, and even it tells you to add this where thing, but I don't understand what's up with that. I understand what is where, I understand what is like bounds and stuff, but I have no idea what's this. But yeah, I guess it may be possible in future future Rust. But this is, you could do it easily using Zig, and even more advanced than this. So yeah, that's just something I like about Zig. And also, of course, like in safe is a bit painful in Rust. but whatever. So anyways, let's go back to our thing here. So we gotta find some letter or like some character that is uppercase. Find. Is this what we want? I don't think. Or is it? Well, we could give it a closure. So yeah, I guess. Maybe. S.find C. If C is uppercase, and what that would actually return, it would return an option. Select the index. Okay, great. Well, we know that for not really. It can be the fact that like, yeah, so you have to handle the none case too. So nice. So well, in the none case, we just return it as it is, which is interesting. This would give me the opportunity to give you some tip here. We'll see. Anyways, so for now, let's just say if let sum index, I guess, is equal to this, else just return s as it is. But well, we gotta allocate anyways because the interface needs that in this case. And actually I could probably just say this if I do it correctly. Like if I say, yeah, okay. So here, what I should do. So I basically want to insert, all right. So let's first of all make a string. And this string would be new with capacity, like with capacity would be s.len plus 1, because we're basically just going to add like one space right there. I'm just making sure we do one allocation. And after that, what else? We're going to say s.extend, I believe. Okay, great. What else? s.extend. Yeah, but we want to extend up to the index, I believe. And then we want to add like a space and then add the rest of the string, I think. Let's see. So 0 up to the index. Cannot borrow immutable local. Okay, mutable. Here. And let me just do to do here so it doesn't keep on erroring here. And basically s index. Yeah, can I do this? It's not an iterator. Can I turn it into an iterator? Not really. Okay, how would you add? Oh, I guess push string, right? Push stir. All right, there you go. So up to the index, then we're gonna push a char, it's gonna be a space, and then finally we're gonna push the rest of the string. Up the rest of the string would be from index up to the end, and there you go. And finally you're just gonna return s. Though we could have done it better actually. We could have also done this format and then a space and then again this, and then you would basically say this and then this, and let's go. I'm not sure which one is better, but this is nicer, I guess. At least in terms of preference, I'm not sure which one is better. But anyways, type annotation is needed. Okay. This should be char. All right, great. What's up? Camel casein test. Oh. Well, that's a trap. Interesting. So it could be that it's before is a space. All right, gotcha. So how are we gonna do this then? Interesting. Basically could be before a space. I guess maybe a window here would be good. Because you need to see like if the previous character is a space or not. And in fact, it's probably not just +1. In this case, for example, we're going to be adding 2 spaces. Interesting. Well. Yeah, let's just do it like this. So let's just say as let's say a string here is equal to string u. Let's just go through s dot iter chars. It's very annoying that string doesn't have an iter. Anyways, so chars dot join or what? Dot window, yeah. Dot. There's even map windows, interestingly. There's even tuple windows. Ooh. Return iterator of all contiguous specific size. That's interesting. And there's circular tuple window. Oh my god. These are part of iter tools. And I'm thinking like the standard library got a boost or something. Yeah, these are part of, except for the map windows. Yeah, pretty much. For that, let's just go with tuple windows, I think. And well, for xy or ab, whatever. And let's see, type mismatch string here. And here we got 2 characters. Now, basically, if b, but hold on, we also need the index. So let's also grab and enumerate here. And with that, we're gonna take an I2, basically an index. There you go. Okay. Now, if b is uppercase and a is equal to a space, okay, fine, just do it this way. Okay. Now, and not equal to this, then we're basically going to say string dot oh. I just say here probably is to string actually. And then string dot insert. Oh, the problem with that though is that once we first insert something, it may invalidate the stuff before. Alright, That is interesting. So we could counteract that by, I guess, iterating in reverse. Because if you're iterating in reverse, even if you insert something, it wouldn't matter for the values before it, I guess. Yeah, that's interesting. Okay, fine. So let's just say s.chars.rev. Do I want to reverse that or that? It doesn't really matter that much, I think. But yeah, let's just reverse this. Tuple chars is not satisfied. Okay, we cannot really even reverse that in the first place. What about this? Doesn't seem like either. Yeah, okay. So let's just go with this one then. All right. But then we also have to reverse these. BA. But then we also aren't getting the correct the correct index, because it got reversed. So we gotta reverse the I itself too. Okay, fine. If B is uppercase and A is not equal to which means we have a camel case here, right? Yeah, I think so. So here what we're gonna do, we're gonna basically go ahead and say string the insert into the index. Well, we're gonna say s.len, is it? I think so. Not sure. Or maybe string len. We'll see. We'll see how it goes. So basically we gotta reverse it, right? And here we gotta give it like space. And this could be mutable. Let's see. Let's see. And of course we got it wrong. So camel casing. So this is what we got. Okay. So I need to do a -1 or +1. Okay, we actually done it. Interesting. And of course we had to reverse because we're did we really have to reverse? Let me see what's gonna happen here if we didn't reverse. Yeah, there you go. And yeah, because like I see, yeah, when you insert multiple things, like the iterator gets, yeah, makes sense, right? So I have expected that before it happened. Let's go. All right, nice. All right, so you got the solution to this, though it could have been, but anyways, fine. Anyway, attempt. I need something here. Oh, tuple windows, we got it from here. Iter tools, and honestly iter tools is pretty handy. And let's go submit, and let's see the other solutions. For C in s.chars, If C is uppercase, rest.push. What? How he's actually guarding against having a space before it? Ooh. If C is uppercase, push a space, then in either cases push C. I'm not really sure how he's guarding against that case. To account for that may start with a capital letter. I'm not sure what's happening here. This is weird. Weird. Anyways, C is uppercase format. So chars.map pad uppercase dot collect. Well, here you're allocating a string, and for every single one of them. Flat map. If C is ASCII uppercase, then I'm very confused on how they guard on that other case without accounting for that space. Like this one, I'm kind of confused. Anyways, whatever. Let's go to the next one. Next kata. Write a function stop. Knips. What? Write a function that takes in a string of one or more words and returns the same string, but with all 5 or more letter words reversed. But with all 5 or more letter words reversed, just like the name of this kata. Okay, so stop spinning my words. Damn, that was hard to read. String passed in will consist of only letters and spaces. The spaces will be included only when more than one word is present. Will be included only when more than one word is present. Okay, so basically the words that are more, like there are 5 or more letters, should be reversed. Hey, fellow warriors. Hey, Wolf. This is a test. This is another test. This is written a test. Okay. Gotcha. Train. Let's go. Spin words. Spin words. Okay. Emo Cleo. Welcome. Okay. Let's see how we can do this. Well. And this is a test. How to start about this? I guess we could try to. Is it possible? Well, it is indeed possible that like sometimes you're just gonna get perfect sentences where you don't need to do any transformation. And I'd like to actually tell you about this before, but I forgot. But of course, in this case, in this test, we cannot really do something about it because you just have to return a string. But like in real world, if you really have this problem, then you probably want to do something like this. Like you would have, let's just do it something simpler, like 2 lowercase or something like that. And let's say you get a string, right? Now the naive way would be to just say this to to lowercase, right? But the thing is, you would allocate in, like, it could be that this words is already lowercase, and at that point you're just allocating a new string for no reason. So what you could do, you could use a cow here, which is copy on right, and cow string, I think. Yeah. And then basically, you gotta check first if that is already lowercase. So if words is lowercase, there's no function like that in the standard library? No way. That's stupid. Is prefix of, is suffix of. Fine. Words dot. Is there all maybe, or no? Let's say if words dot find find some C that is lowercase or uppercase, actually, yeah, is uppercase. Match types expected count. Okay, so if we find some uppercase letter here, then fine, just go ahead and turn it into lowercase, just allocate, you know. But of course here we gotta say now cow owned. Otherwise, if the word like already doesn't contain any uppercase letters, which means we're just gonna give in the same string. And actually this should be, if let's okay, and otherwise, if other than this, we could just say this, actually say is none or is some. Yeah, if it's some, if we find some uppercase letter here. Otherwise you would just return cow borrowed, and you just gotta give back the words itself. What's up with this? Expected string but found str. Huh. That's interesting. Weird. Yeah, this seems to work. Okay. Char. And there you go. So like if the thing is already lowercase, then we're just gonna give it back the same thing. We're not gonna allocate any string at all in that case. We're just gonna give back the same string. Otherwise, if there is indeed, and we want to do transformation on the data, on the input data, then we actually allocate a new string and pass it, basically. So yeah, that's just a little tip right there. But anyways, and it also applies here, because for example here, spin words, this is a test, like it is the same output. So here you don't need to allocate. But in this case, in this test, like you just gotta give it string anyway, so we cannot give it cow here. All right, fine. Now like the naive way would probably be like split, I think. I'm not sure if I could do it better, but let's see. Word split. And what else? This method takes one argument. 0 arguments were supplied. You give it pattern. Okay. Is there split white space, I believe? Yeah. Interesting. Let us go with ASCII white space. There's no Unicode stuff here, so fine. And now I got that. This actually wouldn't really allocate, would it? Yeah, I don't think it would. It just gives us an iterator, which is nice. Okay, great. So it would be the exact same capacity. So let's just say, I guess, let output, or I don't know what to call it, and let's just say string with capacity, the same capacity, no, len, right? And here we could just say for, or like dot split ASCII white space dot for each what this is gonna be, I guess s, right? And we're gonna see if s dot len here is greater than 5 or equal to 5. So basically greater than 4. Then what we're gonna do at that point, we're gonna say output dot extend, I guess, or dot push str, maybe, we'll see. Extend s dot reverse, well, the iter first, chars dot ref, and of course this should be mutable, and else otherwise, okay, otherwise what we're gonna do here, we're basically just gonna give it the exact same thing. So push str s, wait, what is the criteria something being reversed? If the length is greater than or equal to 5, yeah, greater than or equal to 5, at least that's what I remember. So here, what's up? Let's give it back the output. And what's up with this? Great. So here we're using extend because this is going to be an iterator. Here we're using push str because this is going to be a str. So if it's greater than 4, then we're just going to take in the iterator chars iterator or string. Then we're reversing the iterator. And then we're extending the output with that. Notice that here we're not allocating at all. We're just having one allocation. And then push strs. I think that should do the job. Okay, what I missed? Yeah, I forgot about the spaces. Yes. Well, for that, we're just gonna say output dot push. Is there like a char white space constant or something like that? Not really. Fine. Output push. And what's up again? Did I miss something? Yeah, the end of it you don't want to push. Interesting. Well, how are we gonna do it then? Well, we could do it too simply by just like adding 1 to the capacity there and just like removing the last character. That would be the least friction method of fixing this, I guess. Like, and just at the end of the day, just say output dot pop, maybe. Yeah, in wrap. Then we don't want the results, which actually works out. But can we do better? Can we do better? I don't know. Let's see the solutions of the other people. So spin words. Did I use other tools by any chance here? Yeah, I didn't. So okay. Attempt. Okay, submit. Okay, split ASCII white space. Map word, match word dot length in greater than or equal to 5. True word dot chars dot ref dot collect. Oh my god, you have done a big problem here. False word to string. Damn. Oh well, I guess we have like different priorities. Basically, he's allocating strings here. He's allocating a string here. And he's allocating a vector of strings. And he's joining, well, it's not a vector. Like, yeah, the strings are just moved from here, but you got the point. Like, we're allocating a UVec. So basically, a string for every word and then a vector. And then you're joining, so you're making another string again. Damn. Okay, let's see the other solutions. Split white space. Map x if x left. Collect. Again, same problem. Else x2 string. Same problem. Same problem. Damn, bro. Same problem. Come on. Like, no one really cares about allocations. That's crazy. String new, no from capacity here. Split white space plus equal delim. That's weird, but yeah, same problem. AUX helper auxiliary. Okay, word chars take 5 count, not equal 5 push. Oh wow, well, hold on a second, where we're actually, okay, so push str word out dot extend word dot, great, at least for this one. Word dot chars dot take 5. Why take 5? Okay. Dot count not equal 5. I see what you have done there. Great. With capacity, great. Split white. Okay. Split white space. Either next AUX word mute out. Out dot push. Great, 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 great. How did he handle the space problem that we had? Let's see. I'm not sure, but anyway, that's good. And this guy have used the cow here. He pushed first word, then space word for everything else. Oh, okay. Word split white space. Why this guy's using cow? Like, you can only return a string, am I wrong? Oh. What? Well, you're allocating here anyways. Not sure. Oh, okay. So I see what he's doing here. I see. But at least he made an effort. I see. So basically, like when the length is greater than equal 5, which means that he will leave the string as it is. Actually, he would need to reverse it. So he just owned, he have returned the cow owned here. Hold on. Oh yeah, okay. And then here he just borrowed it. So at least he tried. But you still have this vector here, and it's allocated for every single word that is reversed. But anyway, at least he tried. At least he's not allocating for words that doesn't change. So yeah, spin words, word split, map, word if word len, collect string. Yeah, same problem again. Return split white space, map, return if word dot len less than 5 word dot toString. Else, yeah. Anyways, so I think let's go to the next one then. Alrighty, a narcissistic number or Armstrong number. Oh my god, let's go. We got numbers now, finally. Is a positive number which is the sum of its own digits. Which is the sum of its own digits. Each raised to the power of the number of digits in a given base. In this kata, we will restrict ourselves to decimal base 10. For example, like I never really understand the descriptions. I always go for this. But anyways, for example, take 153, 3 digits, which is narcissistic. 1 to the power 3 plus 5 to the power of 3 plus 3 to the power of 3. So basically you're taking the digits to the power of how much digits you have, and then you're summing it up. Great. It's giving you 153. But then what you do, and which isn't, but how do you know if it's narcissistic or not? Oh, which is the sum of its own digits. Okay, so when you do all of this, it would give you the same number that you have started with. Great. I'm not sure what this is useful for. Okay. And the 1652 4 digits, which isn't. Great. The challenge, your code must return true or false, depending upon whether the given number is a narcissistic number in base 10. This may be true and false in your language. PHP. Error checking for text strings or other invalid inputs is not required. Only valid positive non-zero integers will be passing to the function. All right. We can use our into iter, like the digit iterate that we have made before. I haven't skipped it around, so I gotta rewrite it. That should be pretty simple. Okay, let's train this. So narcissistic. Okay. Let's copy this stuff. Let's keep iter tools. Hopefully iter tools actually have that already. Like, come on, iter tools. Let's see if it does. That would be nice. num.to, and that doesn't seem like, yeah. Why? Anyways, fine. So struct digit iterator num. Now I could do this inline, but it's kind of like it very confuses me. So anyway, here use 64, and then let's just say struct digit iterator and impl digit iterator new, and let's go. It's gonna return digit iterator. Well, of course we're gonna need the number first, so and also call this something good, and here use 64. It's gonna give back self, and it's gonna be digit self number basically. And now we're gonna implement iterator for for digit iterator, right? And let's just say real quick type item, I think, is equal to 64, which is basically the one that we're outputting. And by the way, it's like creating iterators in Rust is very simple. Like in other languages, like especially C++, like if you want to use, like you want to make a view iterator or something like that, I don't remember exactly. That was crazy. I didn't even know where to start with that, but anyways, it's just super overcomplicated for no reason whatsoever. But anyways, let's go next option, self item. All right, so basically, if what we have done before, if self dot number is equal to 0, is it? None. Yeah, and then basically we're gonna say self dot number. Well, we're gonna get the digit here. Self dot number modulo 10, right? And we'd like to just return some digit, but of course we gotta advance the iterator first. Okay. And here let's just say self dot number. Yeah, divided by or equal to divide assign, right? 10, basically the radix essentially. So we could even make this more generic by having the radix here. So huge size. Also, I'm probably gonna try to add this maybe to iter tools, like contribute this to iter tools or something like that. Anyways, I'm not sure though how much useful it is, but anyways, at least for me it's useful in this case. Usize radix. Doesn't have to be usize. I mean, let's just go to 64 so it matches anyways. Fine. Although honestly, whenever I'm not sure about the number, I just go with usize. But anyways, radix. And here, instead of doing this, we could just go with self.radix. Now honestly, I'm not gonna save this, right? I'm gonna make this into its own file really, because I'm gonna be using this a lot anyways. So narcissistic, let's see. All right, so let's create an iterator now. And then we're basically gonna how it was working again. 1652 and power to the digits count. Okay, so I gotta actually get the digits count first, actually. All right. Or do I? Can I do that without the digit count first? Otherwise, we're gonna be needing to iterate twice. Or otherwise allocate, which I don't want. Let's see, take 153. Yeah, we just have to iterate twice. So let's get the digit count here. Let's say digit iterator new. Here we're gonna give it the number, comma the radix, which is 10. And then we're basically gonna say digit count. Okay. Can I just dbj this digit count? Let's just say false for now here. And let's go, doesn't implement debug. Oh yeah, well, we're gonna count this. Digit count equal to 1. What was the right? True. So yeah, indeed it's 1, right? Correct. Great. Just wanted to make sure. Anyways, so we got the digit count. Now let's give the digits itself. And for the digits, it would basically be digit iterator. I mean, we could make the iterator once actually. And then we could just get the count, like digits count is equal to digits.cloned, which clones all of its elements. All of its elements. Not sure if I really want to do that. No, let's just, fine. Yeah, let's just do it too simply like this. Anyway, never mind. And let's just say digits, this is digits count, and then let's get the digits. Copy, paste, fine. All right, great. And this is the radix here is equal to 10, radix. And there you go. Okay, what's next? Now we gotta basically, well, it's a power. If it was multiplied, then I would use something like a dot product, I think, if I remember. But anyways, so first I gotta create an iterator that repeats the digit count on how much digits we have, if that makes sense. So, and then we gotta zip it. Yes. All right, let's say digits, oopsies, digits.zip, yeah. And then let's say digits count dot repeat. How do you create an iterator that repeats some elements? Great. And that would repeat digits count. And yeah, now what we gotta do with this? Yeah, we gotta make the power off. Or otherwise, instead of doing it this way, yeah, just fine. Let's just go with map, I guess. But yeah, let's just be fancy. Let's go with this, and what else? Come on, where is it? Now we're gonna basically do power off. Dot map a comma b. And we're basically gonna say a to the power of b. Or in fact, we could probably say map. Well, like pow. I'm not sure. Function is expected to take a single two tuple. Okay, so no. No. Okay. No implementation for U64 usize. YB is usize because it's a count. Fine. Just make it. I guess make that U64 anyways. And let's go. Now we got the map stuff. Now we gotta sum it up. And yeah. And this should give us, I believe, a U64. And then we're just gonna basically check if the sum is equal to the number. Does this make sense? Let's see. And no. Expected true, actual false. Righty. Alright. 1 to the power of 3. 5 to the power of 3. Am I doing it in the right order though? 1, 5, 3. Yeah, I am. So not sure what's wrong here. Okay, let's say debug. And let's see what we got. So the number is 7. The digits count is 1, which is correct. And then the digits. Okay. So here, well, it skipped over everything. So input 7 actual false. Weird. Let's go to this, or this actually, debug again, and let me make sure this time to really go through it, I guess. Zip new. Damn, that's a lot of stuff. Well, that's weird. So let's do something interesting here. Passing the value on. Okay. Or actually we could just say this, really, just say A or whatever, and do this. So type mismatch, good, expected, yeah, because it's a statement. Fine, and let's go. This would give us a bit of like some debugging at least. See what's happening there. Here we got 7 and 1. 7 and 1, which is correct. And then we're mapping that to a to the power of b. So 7 to the power of 1, which is 7. Then we're summing. Oh, summing what? Summing all these powers. Which, yeah, should be correct. But what was wrong? Incorrect answer for n equals 7. Expected true, but actual false. That's interesting. Let's say this is the sum, okay? Let sum is equal to this. Let's try this out. And let's see what we got. Let me say dbj sum. And what is the sum here? Is equal to 6. Why 6? Oh, that's interesting. Why? Okay, let's see what we got here too. Inspect dbj. That's a lot of A's right there. Fine. And let's see. So A equal to 6. So yeah, something is weird happening, I guess, at this stage. Yeah, this stage. Because here we're getting 7 and 1, which should map to 7 to the power. And OBS for some reason have disconnected and it's back. Okay. And I can't believe 4 hours have passed already. Interesting. Could it be this conversion is playing with something? Oh, could it be this operator is not what I want? Probably. Weird. I mean, it would be more safer, but anyway, whichever. And yeah, I believe that's it. Now I don't think I'm gonna need to inspect stuff anymore, because probably I was just using the wrong operator. So yeah, let's see now. And yeah, that was correct. It's just that we were using the wrong POW there. And there you go. Nice. Nice, nice, nice. So digits expected is equal to number. And there you go. Well, here we could say you know what, let's just remove this. Let's keep it radix 10. And here, where we're gonna need the count, we're gonna need it just here. So let's make a little bit of a one-liner here, hopefully. And yeah, there you go. Nice. There you go, one-liner. There you go. It's pretty cool when I write such liners. Pretty nice. Okay. Std iter repeat digit iterator new. Let's just import this repeat, I think, so it looks nicer. And yeah, don't need this. And now let's just copy this and let's go. You got the right iterators, you can make a one-liner, which is nice. Though I could probably try to implement it as a trait or something like that to add it to the number itself. So I could like say number dot digit iterator or something like that. I'm not sure how that works exactly, but well. Anyways, whatever. Let's just attempt now. And submit. Ready. You have unlocked a new privilege. You now have the ability to weigh in on the ranking of beta kata. What's that? Anyways. You have ranked up, come on. Bruh. Okay, so what's up with this? There you go, it's using toString. I'm not doing any allocations here, so that's nice. That's fancy. He's using log to get the exponent. That's interesting. So like we could use that to not have to go through like to make it like to iterate twice on the digits. We could use this trick of basically using the log of 10 or the log of the radix basically. Dot seal as u32. That's the exponents. It's basically the digit count essentially. So we could make our yeah, it's basically very similar to our case, but like there's this little trick here, and also there's no iterate. It's just like inline. I mean, we could snatch this, I guess, and put it here in repeat here. Because in our code currently we're like iterating twice on the digits. So once for getting the count and once for but yeah. Number as if 64.log 10. Let's see. Let's see if this works. Yes, it does. Nice. Do I really have to make it f64? It's probably is. I mean, it can't be just there for no reason. Yep. And yeah, this is pretty interesting. Great. So right now we have one iteration over that. But anyways, oh my god. Hash set. That is interesting. Digits, temp. Yeah, that's kind of what I'm doing, but is using the vector unallocation in digits iter somehow. Yeah, the mathematical answers are always interesting. Yep, there you go. So fold. Let's go next kata. Heads up and look the full potential of your account. This kata is part of a series on the Morse code. Okay, we're getting fancy right now. After you solve this kata, you may move to the next one. Part of series 1 on 3. In this kata, you have to write a simple Morse code decoder. Oh, okay. I never done that in my life. That's interesting. While the Morse code is now mostly superseded by voice and digital data communication channels, it still has its use in some applications around the world. The Morse code encodes every character as a sequence of dots and dashes. For example, the letter A is coded as... Yeah, I have no idea how Morse works. The letter A is coded as that. And letter Q is coded as that. And by the way, hold on a second. All right, fine. Q is coded, and digit 1 is coded as that. The Morse code is case insensitive. Traditionally, capital letters are used when the message is written in Morse code. A single space is used to separate the character codes, and 3 spaces are used to separate words. Okay. For example, the message "Hey Jude" in Morse code is this. Note: extra spaces before or after the code have no meaning and should be ignored. Before. Oh, okay. In addition to letters, digits, and some punctuation. In addition to letters, digits, and some punctuation, there's some special service codes. The most notorious of those is the International Distress Signal (SOC). That was first issued by Titanic. That is coded as that. These special codes are treated as single special characters and are usually are transmitted as separate words. Your task is to implement a function that would take the Morse code as input and return a decoded human readable string. For example, decode Morse should return "Hey Jude." For coding purposes, you have to use ASCII characters, not Unicode characters. Okay. Dot and minus. The Morse code table is preloaded for you as a dictionary. Feel free to use it. Well, if that's the case, then it should be very simple to do, actually. I guess. Or am I missing something? I'm probably missing something. We'll see. All the test strings would contain valid Morse code, so you may skip checking for errors and exceptions. The C# test will fail if the solution code throws an exception. Please keep that in mind, because otherwise the engine would simply ignore the test, resulting in the valid solution. Good luck. You may try yourself at Decode the Morse Code Advanced. Ooh. Okay. I guess let's try it. Fine. Let's see. Oh, preloaded. Okay. Alrighty, mode preloaded. Decode Morse. Coded str. So since it's preloaded, I cannot code in here. Okay. Great, okay. So what we gotta do? Okay, notes. As a dictionary, feel free to use it. So I think we're basically gonna be mapping the characters to whatever is in the hash map. And other than that, we're gonna basically map, I mean, it should be just that. I mean, if I'm not sure like what kind of stuff is in there. Oh, hold on a second. Oh, righty, hold on. Well, this guy is actually doesn't have like a, and then you would convert it into. Otherwise, you actually have these, and then you would convert it to these. How? Of dots and dashes. What? Like, they don't even have a predefined length. But I guess we could just like reverse the hash map then. Would that work? Not sure. Let's see, I guess. Like, I guess let's try to reverse it, maybe. Though, honestly, let me just grab this anyways. Or let's just maybe try something real quick here. And, oh, by the way, let me just save this. And let's just make it into something, the iterator. Oops. Now let's see. Digit iterator, let's make it public, I think. Public. And here, this guy should be public. And this should probably be public. Do I need that? No. Okay. What about now? Import, and let's go. I don't think I need this guy. And yeah, that's it. So yeah, pretty cool. Pretty cool. Great. The other thing that I liked is how do you like can get the digit count like this, so that's also nice. So log, is there like some log that you would give it the base? Great. So log and the number, 10, and I guess maybe integer or something. Oopsies. Weird. What's up with this? Takes one argument, but two arguments were supplied. Huh. What was happening there? Oh, I see. So we gotta only give it the base, which is 10 in this case. Makes sense. Okay. That was pretty simple actually. So yeah, fine. Anyways, so let's just go ahead and remove these anyways. So I'd like to keep around the iter tools. what is it called again? There you go. Not sure what I'm meant to import here again. What was it? Editor tools, I guess. Yeah, probably. Anyways, let's see what we got here. Or let's just write something anyways. Let's write something real quick here, whatever. And let's see. So basically we have some sort of a hash map, right? So that would contain the codes. Let's just create an empty hash map here. Fine. And this would basically be, this hash map would be a string to a string. Great. Okay. Now I'm gonna have another reversed hash map. I'm not sure if I could just like use reference strings here. We'll see. A hash map. Like, is there anything that would actually do that for us even? I don't think. But there's here rev. But I guess rev maybe would just like iterate in reverse order of the hash map. No, that's not what we want. Okay, so let's say hash map, I think. And let's just try to go with str if we can, like, not allocate the strings, would be cool. But I'm not sure how the borrow checker would deal with this. So ref codes, let's see. Dot push, I guess. Okay, let's go through all the codes. So for coding codes or whatever, and let's say ref codes dot, I guess, insert. Insert the key. Now this is gonna be quite different. So like we're gonna get key and value, and then we're gonna insert v and k, like the value and the key. So we gotta be careful. Like the values should be unique, basically. Cannot borrow immutable local variable ref codes as mutable. Well, actually we could own the thing. Yeah, we could own the thing. So it doesn't really matter, because we're not gonna need that anymore. So here we're just gonna be moving the strings, I guess. So that's fine. Immutable ref codes. And yeah, right. So for example, if you have like, I don't know, let's say, I don't know, let's say key value here. Cannot borrow immutable local variable codes as mutable. Good. Okay. Mutable are incorrect because these gotta be strings. We could say dot into, I believe, yes. So we could turn it into an allocated string, an own string. Okay. Now this ref code should have that dbj. Could activate Copilot here. So you could make the test for me real quick. Super bad, but at least it generated the boilerplate code anyways. Alright, so let's just run the main function here. pretty quick, and let's go ahead and run the test. And as you can see, it got the value key, but the problem comes in when you have something like this. So like you have the same value but different keys, and at that point what happens is where's the stuff that got printed though? There you go. Okay, so instead of having two entries, right now we're gonna have one entry value with the last key. So we're not gonna have to. So we gotta guard against this. I'm not sure if like it doesn't map one to one, but we'll see. So if ref codes that contains key V, then well, panic. Oopsies. Panic. Values aren't unique. Or let's say value V isn't unique. Because there you go. There you go. And what is the panic? Value isn't unique. There you go. So that's nice. But yeah. So yeah, so right now what I'm gonna do is do this. Put it here. And here we're just gonna have use preloaded Morse code. So Morse code is equal to that, and here in Morse code tests real quick here. Yeah, let's use this. Let's just see if this compiles and stuff. Cannot find value ref codes. Yes, Morse code here. Just one cell sync lazy hash map string is not an iterator. What? What happens if we do this? The trait bound string is not satisfied. Huh. Okay, into iter. Yeah, I think now right now it's good. So let's just say string new. Insert vacay kv or what? No, it should be vacay because basically I'm reversing the Morse code table, because the Morse code table that they give is just like giving you this, guys, then this. Oh, okay, but like the encoded is exactly this. Not sure how I'm gonna go about it actually. I really have no idea about Morse code. Like, can it be any length or what? But what's happening here, by the way? Cannot move out of dereference of one cell sync lazy. Alright, cannot move it. So I cannot do this trick where I move the string so I don't have to allocate. So interesting. Okay, let's try to just store SCRs then. Let's try to store STRs instead of strings. And then here, the trait bound STR string is not satisfied. I think iterator consumes it. I want to consume it, but it doesn't let me because that's a lazy, like a global basically. But I do indeed want to consume it. Borrow string is not satisfied and contains key. What contains key expects in this case though? But when I borrow, then you tell me no. Required by bounding disassociated function. Yeah, I have no idea how Morse code really works. And no idea what it's talking about here. It is implemented for string. But yeah, even if I fix it, I don't really have any idea how to do this. Because yeah, A is like this, Q is like this, and digit 1 is like this. Yeah, you're telling me this, but like you're not telling me how much characters it would be, or at least minimum and a maximum and stuff like that. Oh well, let's just skip this. Write number in expanded form. Oh, okay, that's simple. I thought he was talking about something else. You'll be given a number and you will need to return it as a string in expanded form. For example, expanded form 12, 42, 70, 34. Numbers will be whole numbers greater than 0. Okay, if you like this kata, check out part 2. Part 2 should return 10 plus 2. This should be very simple. We can use our digit iterator here though. Could probably be simpler. But let's see. Let's see. Okay, let's go this expanded form. 10 plus 2. I guess let's start by using my own iterator that I've just made. So let's digit iterator. So basically digits, right? So digit iterator. What's up? Oops. What's happening here? Why this doesn't... Oh. Okay, I removed mod here. Alright, I see. Okay. So here we got digits. Nice. We're gonna enumerate that. So, enumerate. And then we're gonna get digits. I don't remember, was it from like the smallest digit or the biggest digits? Let's see. Let's see. Index I basically, and then you got digits. Of course, I need a triple here. And let's see. Let's just return an empty string for now here. And I just want to see what is these values just to make sure. Hello, Phase Doctor. Welcome to the live stream. Uh, 10 plus 2. Okay, so we got 0, 2, 1, 1. What is this value? What are you doing? Just passing through this kata stuff. So like you just get challenges and you have to code them in Rust. And I try from time to time to give some tips about Rust or even explain some stuff about Rust possibly. So yeah, that's basically what I'm trying to, or what I'm doing. So yeah, let's see what's happening here. 0, 2, 1, 1. 0, 2, 1, 1. D2, 1. Nice, thanks. Okay, so what's up with this? Left, right, 10 plus 2. Okay, we're getting 12. And then it's getting 2, and then it's getting 1. So yeah, it starts from the right. Okay. But here, the string would actually start from the other way around. 10 plus 2, 40 plus 2. Yeah, it would start the other way around. Okay. Okay. So let's see what we gotta do here. Well, we could use that little trick to get the count. Like how much digits in the number. It was basically log, well, end log, well, there is an integer log though. Returns the base 10 logarithm of the number rounded down. Rounded down. That's interesting. Let's just try this and see. So before we were using the float version, so like we were casting, then using the log. Keep the work. Thanks. Thank you so much. Let's see. I log 10. So dbj count. We probably gotta add a 1 there. Well, let's see. So count 1. Okay, so we gotta add the 1 here. So this seems to be fine, but we just gotta make sure to add a 1, I believe. Maybe. We'll see. Let's actually go to just some Rust playground or something real quick. Just to make sure I'm doing this correct, otherwise... okay. empty. Well, let's do it here. So, okay. So like if you say this, by the way, the only problem with log is that if it's 0, then it would not work, which makes sense because like when it's 0, like you could just do how much zeros you want. So yeah, but anyways. Can't call method ilog10 on ambiguous numeric type. Cool, okay. Let's give it some numeric type, I guess. Found macro. Yeah. And yeah, this is 1. If I give it 2 digits, 2, 3 digits, 3. Yeah, I just gotta make sure. But seems like we don't have to actually convert it into a float. Just gotta say I log 10 and plus 1. I would guess it's much more efficient, but we'll see. Anyways. Alright, so enumerate for each. Now the thing is, I probably gotta reverse this first. Yeah, probably. Dot rev. Enumerate. And just for convenience, I think I'm also gonna have a map. Where basically you're gonna have like, what is happening with my keyboard? Okay, there you go. And let's go with value in I, and I'm basically gonna map it. The value would stay the same, of course. I already reversed that, and the I would change. We would probably say count minus I as to reverse the enumerate. Actually, I don't really need to. Yeah, I guess so. Basically, I think we could just reverse the whole thing, like including the enumerate. I'm probably missing something here, but let's see. The for each, why I cannot do this? Why cannot? Weird. Anyway, let's just say I digit here in. I'm not sure why I wasn't able to do for each there, but anyways. So let's just dbj I digit, and let's see if we're getting that correct. And maybe let's say I times digit. Found U64, okay. Smash types. Okay, digit. Oh, I cannot. Okay, fine. Let's just say I digit for now. I just want to see. Yeah, I was missing a semicolon this whole time. The tray bound is not satisfied. Yeah, makes sense. Makes sense. Now I see why I couldn't do that. Basically, digit iterator, we didn't make it like a double-ended iterator, so you cannot really reverse it with enumerate. Or maybe not just enumerate, but like the whole thing you cannot reverse it. Because it doesn't implement double-ended iterator. Yeah, makes sense. Makes sense. Basically, if something doesn't implement double-ended iterator, it's either not implemented or it's costly to do. I guess we could try to implement it, maybe. Really not sure. Double-ended iterator with the direction inverted. Let's just see what's gonna happen here if I do this. Oh, it takes some generic. Why? Weird. But basically I probably gotta just like implement double-ended iterator essentially. I don't know if I can implement that. I never even done that. Item. Okay, why the item is not an associated type? Or maybe it could. If I done this, hold on. Impl iterator, double iterator for digit iterator. Okay, but what if I said rev? No, there's no rev here. Okay, so this actually needs another thing. Implement members. So you're gonna need next back to implement double-ended iterator, which basically to like go back from where you came. Well. How can we reverse this? Let's see. I guess we gotta maybe do this. Times equals self.radix. Expected enum option. Oh yeah, okay. And then what else? We gotta get the digit. And then just give the digit. Maybe I'm missing something. This seems super easy. Anyways, let's see. If self number equals 0, then none. Well, that is not really the case in this case. If it's 0, that just means that we have the whole iterator to iterate through. Yeah, I see. Like, how would you actually know that you have reached the end iterator? Like, you gotta keep track of how much times. Ooh, interesting. If self.number is equal to 0. Well, in our case here, it would be like equal to length of the iterator or something like that. And we can actually get the length by using the log trick. Is it? Well, as long as you keep the original number, then you can do that. So, or we could just like calculate that all together from the start. But even then, Actually, not really. Yeah, not really. So like basically what we gotta do, I think we could just say original, for example, and then store the original number, which is basically gonna be number. And of course we cannot, or we're only gonna mutate the number, not the original. And so here we could say if it's equal to original, self the original, then I guess we could just say none, I believe. I'm not sure how double-ended iterators works exactly, but I guess this is how it would be. None, some digit. But yeah, anyways, I'm quite tired at this point, honestly. So I gotta have to stop the stream. It's been around almost 5 hours, which is interesting. Let me know if you'd like more streams like this. This is the first time that I've tried this style of stream. Let me know. And also let me know if you'd like me to try with some other language even, and maybe even some language that I don't know. Let me know what your thoughts in the comments, or especially if you like join Discord, my Discord server, that would be even nicer. And then you can let me know what you guys think, what I should do next, or should I do this such content more. And yeah, hopefully that was interesting. And more importantly, you have learned something. Like I learned a lot too. But yeah, that was it for this live stream, and see you later. Goodbye everyone.